Base 10 blocks can be used for a variety of purposes. One thing that a learner may initially do is use base 10 blocks to create numbers. So for example, they may initially compose the number 73 by showing 10, 20, 30, 40, 50, 60, 70, 71, 72, and 73 using tens and ones. However, it's good for learners to challenge themselves to compose this number in a different way. For example, this learner has still composed 73, but you can see that they regrouped or traded in this 110 for these 10 ones. So they can still count and see that it's 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. So learners are encouraged to practice this regrouping and composing or decomposing numbers in a variety of ways. Learners may also use the base 10 blocks to solve addition or subtraction problems. For example, they may first represent the problem showing 73 plus the 18, and then they would be ready to combine the tens and the ones to solve it. What we're hoping learners will start noticing or observing, if they were to simply kind of count this and identify what was in the hundreds place, the tens place, and the ones place, they would see, okay, there's 0 hundreds, and then they would see 1, 2, 3, 4, 5, 6, 7, 8 tens, and then they would count that there were actually 11 ones. We're hoping learners would realize that this number, which looks almost like 811, is not realistic if we're adding 73 plus 18, especially when we don't even have any hundreds represented. So what we're hoping learners can start to recognize is that in this situation, they can really be regrouping. So we can see over here that we have 10 ones and 1 extra one. Learners should understand that they can regroup these 10 ones and trade it out for 110. So in doing so, a learner should then be able to do the same process and find that it does make sense and is a logical answer, because they now have 1, 2, 3, 4, 5, 6, 7, 8, 9 tens and only 1 1. We can see that there's 0 hundreds, so we don't even really need to put a blank there to represent that. We'd encourage learners to also double check this work by actually counting their manipulatives: 10, 20, 30, 40, 50, 60, 70, 80, 90, 91. For learners who also enjoy other strategies such as the number line or the traditional algorithm, these are other great ways for them to check their learning. For subtraction problems, learners can also practice solving this using the base 10 materials. For subtraction, learners must consider that they're starting with 73, but they cannot add or represent the other 15 with materials because it's something they'll be taken away. This is a common misconception and a common error that happens when they're using the base 10 manipulatives. If a learner realizes they need to take away the 15, they may initially notice that they have to take away 110 and 5 ones. While it would be easy for them to take 110 away, they can see that they do not have enough ones. This is where it's very important that learners have the common understanding of regrouping, because then learners can understand that by bringing in 10 ones and exchanging it or regrouping for one of their tens, this is still going to represent 73. At this point, a learner should be able to now take away the 5 ones, 1, 2, 3, 4, 5, as well as take away 110. The learner may wish to organize their manipulatives in rows of 5 to make it easier for counting, but then they can count their materials to find the answer: 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56, 57, 58. In the same way as earlier, maybe they're labeling it hundreds, tens, and ones. They can see that they have no hundreds. They can see that they have 5 tens, And we can see quickly that we have 5, 6, 7, 8 ones. So at this point, we can see that we've really counted our materials accurately. As mentioned earlier, we may wish to go ahead and also check this using a number line or possibly using the standard algorithm.